Here is the presentation for the paper, Dynamic Heterogeneous Graph Embedding using Hierarchical Attentions from Alibaba Group. My name is Lu Weiyang. Graph embedding is a technique to encode nodes into node-dimensional space by considering network structures and node properties. These learned node embeddings can be used for node classification, edge prediction, and network prediction. However, in real world, graphs often evolve over time and are heterogeneous. For example, there is a user item by party graph in e-commerce. There are two kinds of nodes, user and item, and there are four types of edges: click, collect, add to cart, and purchase. So it is heterogeneous. Besides, we can see that the user interests are evolving over time. So we propose a novel method using hierarchical attentions to take both temporal evolution and structural heterogeneity into account. Basically, there are three attentions. The first is the node-level attention, which is intended to aggregate node embeddings for edge-specific subgraph. Note that, as usual, we describe a dynamic graph as a series of snapshots. The subgraph is separated according to edge type. Here, blue indicates one edge type, green indicates another edge type. If we have two types of edges, then every node will have two types of embeddings. We assume the above-learned edge-specific node embedding just expresses one semantic type of information in a heterogeneous graph. Then the second attention, edge-level attention, is going to merge them. After that, each node in every snapshot will have a node embedding. Finally, the third attention, temporal level attention, is going to aggregate node embeddings across the time snapshots. We use the embeddings in the last snapshot attending over previous snapshots. Then we will have exact one embedding vector for each node. Here is the exact equations for these three attentions. More details can be referred to the paper. One thing could be noted is that multi-head mechanism can be used in node level and temporal level attentions. For the evaluation, we employ two public real-world datasets and one our e-commerce datasets. The evaluation task is link prediction on the last held-out snapshot. We compared many baselines, including the static graph embedding methods, such as deep work, MetaPath2Vec, GraphSage, and Graph Attention Network. And for dynamic graph embedding methods, we compared dynamic triad and die-set. The results show that our method DyHan obtains the highest matrix, which shows the efficacy of our proposed method. So in this presentation, we have shown our proposed dynamic graph embedding method, DyHan, using hierarchical attentions. For the future direction, we may explore more temporal aggregation techniques, such as LSTM or GRU.